So in this video, we are going to be looking at real numbers and how they can be classified according to their characteristics. All right, so the first category of number we're going to look at are the natural numbers. These numbers are those numbers that you first learn about when you learn to count. So we have 1, 2, 3, 4, 5, and I'm going to do ... to show that it continues. So these are also referred to as simply as counting numbers. The next classification of numbers, which includes all the natural numbers, is called the whole numbers. So notice how this segment falls within this other one. And it also includes the number 0. So 0, 1, 2, 3, 4, 5, 6, 7, ... and it continues. Now the next classification of numbers we have are integers. Integers include all of the natural numbers, all of the whole numbers, and their negative opposites. So I'm going to start down here. I'm going to call this 0. So it's going to include your whole numbers. Keeps going, and their negative opposites. So not just 1, but also -1, -2, -3, -4, and so on and so forth. Okay, now the next category of numbers are what we call rational numbers. Now, rational numbers can be written as a ratio, and I'm going to write that as A over B. Written as a fraction. That's another way you can think about it. Okay, so you can take that value and you can place it as a fraction. So what do I mean by that? Okay, well, let's go back and we'll start off at 0 again. So rational numbers include all of the integers, whole numbers, and natural numbers. So 0, 1, 2, but I can also then include the number 2.5. But notice how 2.5, that's a mixed number, I can write it as A over B. So I can change it to its improper fraction. I can say it's 5 over 2. And now I'm in that format of A over B. I also can include numbers that are in their decimal form, right? 7.9 or 7 and 9/10, because we know that these decimals have a fractional equivalent. And these numbers just keep on going. So rational numbers and their negative opposites. So all the same applies on this side. So negative, let's say -1/3, -2, -4.1 is a rational number, -11/2 is a rational number, -6.4, and so on and so forth. They keep going. So for rational numbers, you just can remember that it can be written as a fraction or a decimal. All right, but not just any kind of decimal. It has to be a terminating decimal, because for non-terminating, non-repeating decimals, we get over here to the last category of numbers that does not fall within this, order. These are the irrational numbers. Now, irrational numbers, if they are in their decimal form, they do not repeat, meaning it's not going to be like this -1/3. If I were to put that in its decimal equivalent, that would be -0.333, and I can put the little bar to show that it repeats. So irrational numbers do not repeat or terminate, meaning they don't end. They'll keep on going forever and ever and ever. Can you think of a number that keeps going forever and ever and ever and ever? That's right, pi. So pi is an example of an irrational number. Also, the square root of numbers that are not perfect squares, those also will come out to be an irrational number. Okay, so that's just an overview of our real number system and how we can classify numbers, and check out our next video closely related to this concept.